Okay, so we are moving on to perpendicular lines and parallel lines. Okay, when you get to geometry, you'll do more with these. But what we're focusing on is the equations of their lines. So we've talked about slope, we've talked about points, we've talked about y-intercepts, and all the different ways to write them as equations, right? Just a quick little review. We did point slope. Let's start with the very beginning. If I don't have a slope, how do I find a slope? Not sure? To find the slope, we look at the change of the y, and we divide it by the change in my x. So, like, how did this y turn into this? Did it go up or did it go down? How did this x turn into this x? Did it go left or did it go right? Okay, so we have to find slope if we don't have it first, and this is the m. Okay? The first form that we talked about was slope-intercept form. So that's when you were given the slope, and sometimes we had to find the intercept, but it was y equals mx plus b. Slope was the m, my intercept was my b. Okay. Then we did point slope, which y'all actually really liked and you did very well at. Okay, I'm going to zoom in a little bit here. Okay, point slope was when we did y minus y equals my slope times x minus x. Okay, where the pieces in black, those were always there, right? And then we had one little piece called standard form, and that's just when your x and y are on the same side. And we make sure there's no fractions going on. Okay, so that is all what we did last week. Okay, that's a quick little review to it down. That's a quick little review of just everything we talked about last week. It's all going to come back. We're going to practice more. Okay, remember, if you didn't finish that stuff from Friday, make sure we get it done online. Okay. So going through all of those, for our first example up here, okay, what equation are all three lines written in? Y equals negative 1/2 plus 3. Y equals negative 1/2 x. Y equals negative 1/2 minus 2. But which form? Slope, intercept, point, slope, or standard? Slope, intercept. Right? See how it's something x plus something, and it's y equals? That's my orange. Okay? These are all written in slope-intercept form. Which is y equals mx plus b. So for each of these equations, let's name the slope, name the y-intercept, and then we're also going to graph them. Okay? So my first one, y equals negative 1/2 x plus 3. What is my m? Negative 1/2. And my b is 3, yes. Okay, my slope is negative 1/2, and our y-intercept is 3. Here's digging back. Do you remember how to actually graph this? So a y-intercept of 3, remember these are my x's, right? These are negative x's. These are y's. These are my negative y's. This is a y value of positive 3. B is where you begin the line. Okay? So I'm going to begin with the positive 3 right here. And the m is how you move. We're going to go down 1 and over 2. Down, over. Down 1 over 2. Down 1 over 2. You can do as many points as you'd like. I would do at least 3 or 4. I don't have a ruler right now, so I'm going to do as many as I can so I get a nice straight line. let's call this A. So I can label it. That's line A. What's up? You're going down 1 and to the right 2. And then when I went backwards, I went up and then backwards. I did the opposite. Yeah, so this was down and then over. Okay. My middle line, I'm going to call it line B. Okay. What is the slope for this one? What number is attached to my x? For that middle one. What's my slope? That's the y-intercept. What's the slope? The -1/2. And my y-intercept, he told me it was 0. Because there's nothing technically here. So our y-intercept is 0. Okay. So this time I'm beginning when my y value is at 0, which is the origin of my graph. That's where we're going to start. And I'm going to move, just like last time, by going down 1 and over 2. Down and over, down and over. To go backwards, I can go up and backwards. So up 1, backwards 2, up 1, backwards 2. Just like this. All right, so we're going to call that line B. I'm going to label my third one as C. So we have an A, B, and C now. My green one, I have y equals -1/2 x minus 2. So looking at this one, what is my slope? Remember, that's the number attached to my x. What's the number attached to my x? -1/2. Thank you. It sure has, and yet people still can't answer it. And what is my slope my y-intercept for this problem? It is -2. So my line C is going to start at a y value of -2. And it's going to go down and over 2, as someone pointed out, just like all the other ones did. Okay? So here is line C. So looking at my lines, what can we conclude about them? What do you think? Okay, they're close. Ooh, they are. How do you know they're parallel? They're lined up. They're never crossing over, right? These are all parallel lines. Okay? And that's because they have the same what? Someone pointed it out earlier. They all have the same slope. Very good. So lines have the same slope and they have different y-intercepts. So they all started somewhere different, but they all moved the same way from that point, and that's what made them never cross over each other. Okay? So from this, we can see that parallel lines have equal slopes, which is that m value in our equation. So if they have the same m, they're going to be parallel lines. They're going to move the same way. They will never cross over. I have y equals 3/4 x plus 2 and y equals -4/3 x plus 1. What is the m for the first function? I'll label this as a. It is 3/4. Okay? And for the next one, we'll call that graph B. What's the slope for this line? Almost. Negative 4/3. Okay. What's up?
They just posted my books getting
I'm sorry. So when I graph these lines, for line A, where am I going to start the line? We're going to start it at 2. We're going to begin at 2. So +1, +2. And my slope is going to move. 3 is positive and 4 is positive. I'm going to write it differently. I'm going to do this. 3 over 4. So it's going to go up 3 and it's going to go over 4. So 1, 2, 3 over 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. So up 3 and over 4. If you want to go backwards, we'll go down 3 and then backwards 4. So down 1, 2, 3, backwards 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. Like that. Okay, here's my line A. Line B is starting where? It's starting at 1 this time. So we're beginning at a +1, so really close to the other one, but not exactly. And my slope is negative 4/3, so this time we're going to go down 4 units and then over 3. Okay, so down 1, 2, 3, 4, and then over 1, 2, 3. 1, 2, 3, 4, over 1, 2, 3. Down 4, over 3. If I wanted to go backwards, I would go up 4 and then backwards 3. 1, 2, 3, 4, backwards 3. 1, 2, 3, 4, 1, 2, 3, like that. Okay. Whoop. Oh, that is not straight. Try that again. There we go. All right, so this is line B. Are these the same or different than the ones we just did? They're different, right? They definitely cross over each other. So what do you think these are called? These are the perpendicular lines, yes. And I spell perpendicular wrong every time. There we go. Okay, these are perpendicular lines. Their slopes. So look at it. It went 3/4 and then negative 4/3. So I went from positive to negative, right? And then the 3/4 became 4/3. What do you call when you like flip a fraction like that? Starts with an R. Almost.
Rotation.
When you flip a fraction, what is it called? Starts with an R.
Rise. Run.
It's okay. This is the first part. We know my signs are opposite. It went from positive to negative. And then the flipping of the fraction is called... Reciprocal. I heard someone say it. Reciprocal. It's the opposite reciprocal. So that means change your signs and flip your fraction. Okay? Reciprocal, yeah. So you're going to change your positives and negatives is what the opposite part means. And then reciprocal means to flip fraction. Like that. Okay, so the big difference is going to be their slopes. If your slopes are the same, they are parallel. Okay, they're moving the same way, they'll never cross over each other. But if we have opposite reciprocals, they're very special. They're perpendicular. This means where they cross over each other creates a 90-degree angle, is what's happening. Okay, it's perfectly hitting it right in the middle. Okay, so this bottom half, let's see if we can label these as parallel or perpendicular or neither. Okay. Now they do have like little symbols if you want to. If you want to parallel lines, have a notation that looks like this. Chase and Tram. Perpendicular, you can use this notation if you don't want to write the word. Those technically do mean the same thing. Okay. Okay, so looking at my first example, so number 5. Okay, all we care about is the slope, right? We care about the slope. So looking at 5, can you pick out the slope? Yes, they're both with y equals mx plus b, right? What are their slopes? It's 2. So that means these are what kind of lines? They are parallel lines. These are parallel lines. All right, number 6. I know the slope of the first one is -3, right? But I have an issue with this bottom one because I don't have y by itself, okay? You can't, when it's in standard form like this, I'm going to come back up. Sorry. I'm going to go back up to the top real fast. Notice standard form doesn't have an m, right? Slope intercept has the m, and point slope has an m. Standard does not. So when it's in standard, you have to rewrite it to where it's one of the other two. So usually you have to add or subtract the x to the other side. So let's go back to the bottom. Let's go back to number 6. Here we go. So let's rewrite this. If I have 3x plus y equals 4, how am I going to get y by itself? Yes, we're going to subtract 3x over. So now it's going to be y equals, I have a -3x and I have a +4. So I have -3x in my first line, and I have -3x in my second line. So what kind of lines are these? They are parallel. So a little extra work to do with that one, but that's okay. All right, number 7. I have y equals 2/3 x minus 4, and I have y equals -3/2 x plus 1. They're both y equals, so we're good. What is the slope of the first one? Yes, what's the slope of the first one?
5, -5.
Where do you see a 5?
Oh, no,
2/3.
Wrong number.
Okay. What is the slope of the second one?
-4.
Sir. The second line. My slope is -3/2. Okay. Did it go from a positive to a negative? Yes. Did the fraction flip? Yes. So can I label this as perpendicular? Yes. Oh, see? I spelled it wrong again. These are perpendicular lines. Okay. Number 8, are they both equal to y?
Yes.
Yes, we like that because we can easily just now pull out our m, okay? It's what's attached to my x. So what number is attached to my x in y equals 3x minus 4? A 3, good. What is attached to my x in y equals -3x plus 4? -3. Are these parallel, perpendicular, or none of the above? None of the above, right? So it switched the sign, but did it flip a fraction? No, 3 just stayed 3, right? So because that didn't happen, this is going to be neither. Okay? If 3 would have changed into -1/3, that would have been perpendicular. Okay? Remember, 3 is 3 over 1. So if that change would have happened, that would have been perpendicular lines. Okay? But that did not happen, so this is neither. You have to have both. Hold on. Let me just finish this front page. Okay. Number 9. Are they equal to y? They're equal to y? You have y equals in the equation? No, we don't. Okay, so we have to change some stuff. So let's change this first equation. I'm going to write them down. Oh, that's not what I want to do. There we go. Alright, so we have 2x plus 3y equals 6. I have to rewrite this one. So how am I going to get y on its own? I got to move the x over first. Okay, so we're going to subtract 2x, if it lets me. There we go. I get 3y equals negative 2x plus 6. And then I'm going to have to divide each piece by 3. Okay, we did this, I think, chapter 3, I think. Where we had to solve for y. So we always have to subtract the x or add the x over. And then if there's a number left, we divide by it. Okay, this is going to give me y equals negative 2/3 x, and 6 divided by 3 is 2. Okay. So now that we're equal to y, what is the slope? Negative 2 over 3. Good. Alright, so now let's compare that. So that was this equation. Now let's do it for the second equation. Okay? 2x minus 3y equals negative 6. I gotta move the x over. My x is 2x. How are we gonna move it? Subtract 2x to the other side. Okay. So I have negative 3y equals negative 2x minus 6. So the 6 doesn't have an x. Okay? So you can't put them together. So when you move your x over, it just gets moved in the front of the equation. Okay? So move my x. Now divide each piece by what number? This time, what's attached to my y? What is it? Negative 3? Okay. So I have y equals negative 2 over negative 3. Gives me positive 2/3. Negative 6 over negative 3 gives me positive 2. Okay. What is my slope for this one? 2 over 3. Okay. Why not? Yeah, good. It is neither, but why? Well, one's negative, one's positive. That's good. I guess if you're saying parallel, they should both be positive or both be negative, right? Is that what you're saying? Yes. And to be perpendicular, one of those fractions need to be flipped. Right? So that's what's wrong with both of them. To be parallel, they should both be positive or both be negative. To be perpendicular, one of my fractions had to flip, and it did not. So this is going to be neither. This is number 9. Okay. Number 10, we have 2x minus 5y equals 5, and 2x plus y equals negative 3. So again, we got to do some rewriting. Okay? My first one, okay, I'm going to rewrite this one. We have 2x minus 5y equals 5. Move the x over. How am I going to move my x? How am I going to move 2x to the other side? Subtract it, yes. So we move it to the other side, up front. So this becomes negative 5y. Yeah, negative 2x with a positive 5. Okay. Now we're going to divide each piece by negative 5. Negative 2 over negative 5, the negatives just cancel. So we get positive 2/5 x. And what's 5 over negative 5? Antonio, what is it? 5 over negative 5. 5 over negative 5. Negative 1. So this equation has a slope of 2/5. Oops. All right, so let's do it again on the other side. The other side's actually going to be easier because see how y doesn't have a number attached to it? So it's only going to be a one-step problem, okay? So we have y equals, no we don't. We have 2x plus y, I'm getting ahead of myself, equals negative 3. How am I going to move that x over? How am I going to move 2x to the other side? Thank you, subtract. Gonna be what? Long? Kind of. Yeah. So we have y equals negative 2x minus 3. My y is by itself. What slope do I have there? I have a negative 2. So I went from positive to negative. Did my fraction also flip? No. So guess what? It's neither.
What's one? Is that number 10, right?
Yes. Woo. There we go. I'm sorry. Number 9 was also neither.
Oh, that's why I put first. I put neither, so number 9.
Yep. Yes, so far I think 8, 9, and 10 have all been neither.
Yes.
This one's there, we go.
Okay. All right, we good? Ready for 11? Okay. You want to go to 12 real fast?
No.
Let's go to 12 real
I'll
fast.
skip to 12.
Okay? Let's go to 12. Real quick. Okay, so with 12, I have x plus 3y equals 4, and then I have x plus 3y, equals 3, and then x plus 3y equals 4. So they both have the same steps, don't they? X plus 3y equals 3. My other one is x plus 3y equals 4. I'm going to come back to it. I want to do this one real fast. They both have the same first step, which is going to be subtract x to the other side. Subtract x over. So I have 3y equals negative x plus 3. This gives me 3y equals negative x plus 4. Both of them, we're going to divide the whole thing by 3. I have y equals negative 1/3 x plus 1. Over here, I have y equals negative 1/3 x plus 4/3. So look at what's happening with my x's. What happened here? They are the same. So what kind of lines are these? They are parallel. Hey guys, what could have given that away at the very beginning? The x plus 3y. They both had x plus 3y on the same side. That was another clue that it was going to be the same slope. Okay? All right, we got one more. I'm going to try to squeeze it in. Okay, ready? So, for my top equation, do we agree that I have to subtract 3x to the other side? Yes. So when I do that, I'm going to have negative 5y equals the minus 3x I just moved, but I still have a plus 10. Right, Antonio? And then from here, we're going to divide each piece by the negative 5 that is still attached to my y. I know this is cramped. Y'all are doing great. Okay. This is going to give me y equals positive 3/5 x. 10 divided by negative 5 is negative 2. Let me zoom in. There we go. Okay, so that was for this top equation. Our bottom equation. Do we agree I have to subtract 5x first? Okay, so negative 3y is still here. I've moved negative 5x to the other side with the positive 3. I know. We're going to divide each piece by negative 3. I have y equals. This is going to give me a positive 5/3 x, and that gives me a minus 1. So I went from 3/5 to 5/3. So what kind of lines are these? Neither again. Because it went from, they're both still positive, right? So the fraction did flip, which is kind of a little sneaky. Okay, so the fraction flipped, but they both stayed positive. So this one is neither again. Yes, we're getting stamps today. Yes.
You know what I said?
Good.